Hi, this is Tom Moore with AWS. This is part 5 in our video series about modernizing applications on AWS. In this video series, our customer, Acme Financial Data Services, has been going through a process of moving their application from a legacy monolith on-premises to a modern architecture deployed on AWS. Let's take a quick recap of where our customer, Acme, is in their journey. In the previous videos in this series, Acme Financial Data Services was able to segment out functionality of the monolithic application. They were able to convert code from an older .NET Framework application into a modern .NET Core application, and they have configured their application to build as a container. Those efforts have resulted in the application being more portable, lower weight from a development perspective, and much more aligned with a microservices architecture. We have all the code stored in a Git repository. In this case, we're using AWS's Code Commit. However, all the deployments in the application are currently being done manually. Acme wants to update their deployment process with automation. This will allow them to ensure the deployment process is done the same way every time. This leads us to the current video and the tasks at hand. Acme wants to fully embrace DevOps as part of their development culture. To achieve this, they want to fully integrate a continuous integration and continuous deployment pipeline for their application. In this video, we'll be implementing the following functionality. We want to automatically build our application on check-in. We want to automatically test our application on build to ensure we don't have any code regressions. We want to use serverless containers to host our application using AWS Fargate. We want a blue-green deployment methodology that allows for zero downtime deployments and allows us to easily roll back changes if an error does occur. We want our deployment to the development environment to be automated and fully hands-off to ensure the process is repeatable. And if all goes well in development, we want to be able to automatically deploy our applications into production. The first step in the automation process is called continuous integration. The continuous integration flow looks like this. A user makes changes to their code and then checks in the code into the Git repository. We'll automatically build the new software version, run the tests on the software, and then if all of this is successful, we'll automatically build the container. Once the build is completed, we're going to automatically push the container into a container registry so that the changes are available for downstream processing. For this section of the video, we're going to set up a container repository in Elastic Container Repository Service, or ECR. We'll use AWS Code Build to perform all of the build tasks on the software, run the unit tests on the application, and to build and push the container. We'll use AWS Code Pipeline to orchestrate the build process, including triggering the build on check-in. For our containers, we'll use a tagging strategy that automatically tags the container with a build number and a latest tag. This allows our development environment to know which build the container is the latest for testing purposes. Now let's see all of this in action. Because Acme has decided on a container strategy for this part of their application, we need to set up a repository inside of a container registry. AWS has the Amazon Elastic Container Registry, or ECR, that we can use. From the main menu, I'm going to select ECR. From here, I'm going to click Get Started. I need to provide a name for my repository. So I'm going to select Product Catalog Repository. For the rest of the settings, I'm going to leave them as default, and then I'm going to click Create Repository. I'll need to save this name for later because I'm going to incorporate it into my continuous integration script. Now let's look at the code in Visual Studio. The code is built as a standard .NET Core Web API. For the main functionality, no changes have been required in order to allow the application to function inside of AWS. The containers that we implement for the application will run behind an application load balancer. AWS's application load balancer provides the ability to specify a health check to determine if the running container is healthy or not. I've implemented that health check via a home controller. My home controller contains a get method that will be used as the health check. For my current implementation, I'm simply returning OK for the health check, but I can extend this method as my application gets more complex. My code also includes a unit testing project that has been built using the standard .NET Core testing functionality. In this case, I have 2 automated tests that will help to test my code for regressions. These tests will automatically be run by Code Build after a successful build. The final addition I need to make to my source code is a build spec YAML file. I have the file here. The file contains several sections. The install section is used to set up the build environment for me to use. In this case, it specifies that a .NET Core 3.1 runtime is used in order to build my project. The pre-build section contains the AWS CLI commands necessary to log into ECR and provide access to my container registry in my account. The build section contains the commands necessary to perform an automated build. The first command tells .NET to build my main project. There is then the .NET test command, which will execute the unit tests against my project. I then have a series of Docker commands that will build my container and set up the tags on the new container for tracking purposes. Finally, we have the post-build section. In the post-build section, we push the new container to the repository. The reports section of the build spec file allows me to identify where we store the results of the automated testing runs. With all of these files checked into Code Build, we can set up our automated build process for our application. For this, we want to go back to the AWS console. The next step in the build process is to set up AWS Code Build. Code Build will automatically set up the build environment and build our application based off the commands that are included in our build spec YAML file. From the main AWS console, I'm going to select AWS Code Build. From Code Build, I'm going to select the option to create a new build project. I need to provide a name for my build. I can provide an optional description for my automated build here. For source code, I'm going to select Code Commit and select the repository for my code. I need to tell Git where to find the updated application code in my repository. For this, I'm going to choose the master branch. You could choose to build your code based off of a different branch or commit IDs or tags, depending on how you manage source control in your environment. Next, I need to set up the actual build environment that I'll use. I can use an AWS managed image or an image that I manage myself. I'm going to choose to use an AWS managed instance. And I'm going to choose Amazon Linux as the operating system. For runtimes, I'm going to choose standard. And for the image version, I'm going to choose the latest version. I'm going to allow the option to always use the latest image for this runtime. Because I'm building a Docker image, I need to enable the privileged access. As with every interaction with AWS, Code Build requires an AWS role in order to interact with resources in my account. I'm going to allow the setup process to create a new role for me with the required permissions. I do need to record this name so I can modify it after setup. So copy the name off to the side. For the build spec file selection, I'll use the option here to use the normally included build spec file. I could optionally insert the build commands manually here, or I could provide an alternate name for the build spec file. I'm going to use the default. For build artifacts, I'm going to choose to deposit the artifacts into S3. Here I can select a bucket that I already have access to on my account. Finally, I'm going to click the Create Build Project button. The build setup created a new identity and access management, or IAM role, for Code Build to use. However, that role will have some missing permissions. I need to update that role to allow access to some additional services before I can use it. From the Services menu, I'm going to select IAM. I'm going to select Roles. I need to find the role that my build project created and edit it. I can see here the permissions that were created. From here, I need to add access to ECR to be able to interact with the image repository. Now my role has the required permissions. I can go back to Code Build and test the build of the project. For my first build, I'm going to run the build manually by clicking Start Build. I can review the settings. In this case, I don't want to change any, and click Start Build. I'm going to pause the video now and allow the build commands to complete. Now my build is completed. Let's look at what's happened. I can see here the log of all the actions that have occurred for the build process based on the commands that were entered in my build spec YAML file. I can see here that the build succeeded. My report history, I can see reports of all the tests that were run on my build automatically as part of the build process. I can see here that 2 tests were run and 2 tests were passed, and I can inspect the details of that view. As the final part of the build process, my image will have been published to ECR. So I can have a look for my container registry, and I can see here the latest image has been published to the registry with tags of a build number, 1, and latest. This will help me later to drive downstream processing. The final aspect of the continuous integration process is to build a pipeline which automatically connects the check-in of my code to the automated build system. The service we want to look at to automate this process is called Code Pipeline. Here, I'll create a new pipeline. I'll give the pipeline a name. Once again, I'll allow the setup process to create a new service role for this code pipeline to use. For my source code provider, once again, I'm going to choose AWS Code Commit. I'm going to choose the repository name and the branch name. I have an option to determine how I will check for changes in the code. I can either use CloudWatch events, the recommended approach, or I can have the pipeline poll periodically. I'm going to use the default recommended path of CloudWatch events. I'm going to add a build stage, and in this case I'm going to choose AWS Code Build, and I'm going to choose the project which I've already set up and tested in the previous steps. At this point, I'm going to skip the deployment stage. Finally, I can review my settings and click Create Pipeline. Once your code pipeline has been created, it's automatically going to kick off the process to retrieve the code and build. This is the same process that will happen automatically when new code is checked in. You can see here in the UI we've successfully retrieved the code, and now we're launching the build process to once again build my project and publish the updated version of the code into the repository. Once again, I'm going to pause the video to allow the code build process to complete. After some time, the build process has completed and our code pipeline has successfully published all our changes. We can review those changes once again by opening up ECR, going to our repository, and we can see a new image has been posted with a new build number and the latest tag. Our tag has moved from the first image to the latest one that's been published. Now, the only thing left to do is test our changes to make sure that we can automatically trigger them based off of code being checked in from Visual Studio. So let's go back to Visual Studio. We'll go to our home controller and make a trivial change. I'll save my change. And then I will go and publish my changes. Commit and push those changes to source control. Once those changes have been published to source control, I will swap back to code pipeline. In a few moments, we should notice that the continuous integration service kicks off and starts building the latest changes to my code. So we can see here, once again, the code pipeline has triggered based on source code changed, updated health check, and now we're once again going through the build process to publish a new updated version of my container to the repository. So far, Acme Financial Data Services has been able to implement a continuous integration system to automatically build, test, and publish updated containers as changes are applied to the source code. The first set of changes means that they can reliably and repeatably build new packages every time the source code is checked in. Now let's look at the next set of objectives. In this next section, we're going to set up the infrastructure required to run our containers. We need to create a Fargate cluster to run our containers on. We need to create a pair of load balancers to access the containers. Because Acme wants to incorporate a blue-green deployment methodology, we'll have two load balancers. This will allow us to swap the deployments. We'll need to create a task and a service definition to use for our deployments. Finally, we'll deploy our initial service manually using the AWS command line to make sure everything is working correctly before we start wiring up the continuous delivery. Now let's head back to the AWS console. When a container is executing inside of AWS, that container needs to have an execution role. We'll first set up that execution role in AWS Identity and Access Management. From the console, let's open Identity and Access Management. I'm going to select Roles, and I'm going to select Create Role. I need to specify the service that the role is going to be used by, in this case, Elastic Container Service. And then down here under Use Case, I'm going to choose Elastic Container Service Task. For permissions, I need the Amazon ECS Task Execution Role policy. I'm going to attach this. If my container required any additional permissions while executing, I could attach those permissions to the container here and now. However, my container doesn't, so I'm going to go Next, Review. I need to give the role a name. Optionally, I can provide a role description, and I'm going to click Create Role. I now have this role available for my task definition. The next thing we want to do is create a task definition for our container. We want the entire process to be automated. So to do this, we're going to be using the AWS command line tools and configuration files for our code. I've already created an empty AWS code commit repository for my code files. Now let's look at the actual configuration files. Here you can see I have a JSON file that's got all of the configuration necessary to spin up my service definition. Here in this file we can see I've got the definition for the execution role my container is going to use. I'm giving my container a name. I'm giving it the address to pull the latest version of my container, defining it as essential, setting up my port mappings. And here you can see I'm going to run my container in a Fargate cluster. This means I don't have servers to manage on my own. After all of that, I'm giving the task a family name. I'll now execute a command via the AWS command line. This command defines the profile I'm going to use, which is defined in my local machine, defines the region, tells us ECS, register task definition, and tells it to use the JSON file that I have here as the input for the commands and the parameters to set up my task. I'm going to run the command now. This has set up the task definition in my AWS account. Here, back in ECS, we can go to Task Definitions, and we can see I have a task definition set up, which corresponds to the task definition in my input file. And here I can see I've got a definition for the task that I can use in the creation of my service. The next thing I need to do is actually set up my service and the load balancers that will connect to the service so that I can run my task inside of ECS and test it. To create my Amazon EC2 application load balancer, I'm going to start at the AWS Management Console. I'm going to select the EC2 service area. I'm going to scroll down here towards the bottom and select load balancers. Let's create a load balancer. I'm going to choose Application Load Balancer from the options. Obviously, I need to give my load balancer a name. I'm going to choose Internet Facing because the application is going to be serving pages to the Internet. And I'm going to choose IPv4 as the address type. For my listeners, I get a default listener of HTTP attached to port 80. Because I'm going to be doing a blue-green deployment method, I'm going to add a second listener for HTTP and allow traffic to port 8080. This will allow me to have two deployments running on the application load balancer and allow my deployment method to swap the target groups. I need to specify the availability zones that I'll allow my load balancer to run in. In this case, I'm using the default VPC or network. I have to choose at least two subnets for my load balancer to run in. I'm going to choose all 5. Next, I'm going to configure security settings. I receive a warning here because I'm only allowing HTTP traffic through my load balancer and not HTTPS. I certainly can add HTTPS if I choose to. At this point, I'm just going to skip past this warning. I need to configure a security group that allows access to my load balancer. This is a stateful firewall that's implemented at the hypervisor level. In this case, I'm going to create a new security group. And as you can see, the wizard is already selected to allow both traffic on port 80 and 8080. Because this is HTTP traffic, we're allowing that traffic to be received from anywhere. Next, I'm going to configure routing. I'm going to create a new target group and give this target group a name. I'm going to specify the target type as IP addresses, the protocol as HTTP, and allow it on port 80. The next thing to do is configure my health check. As we saw when I was looking at the code that I implemented, I have a health check set up on the home controller, or the root path of my application. So in this case, I will leave the default. If my health check was responding at a different URL, I would want to configure this here. I'm going to click Next, Register Targets. Because I don't have any targets registered, I'm just going to skip past and click Review and Create. I can click here on the load balancer name to view my load balancer in the console, and I can see that it is provisioning. For my blue-green deployment to work, I need to configure a second target group. I'm going to click here on Target Groups. I'm going to click to create a target group. For my second group, again, I'm going to choose IP address. Specify a name, in this case target group 2. I need to change my protocol to 8080 to match the second set of IP of ports that I specified for my application. For health checks, I want to have the same health check specified here as I did in my previous setup. I'm going to click Next. I don't want to manually register any targets, so I'll click Create Target Group. This is a second target group set up, and I need to now register this against my load balancer. So I'll swap back to load balancers, and I can see here my load balancer is still provisioning. Here under listeners, I can see the two listeners, and I can see that right now both of these are specified to go to target group 1. I'm going to find the target group that references port 8080. I'm going to click Edit Rules. I'm going to click the option to edit my current rule. I'm going to choose the edit item for this specific rule. Now I can see here I say forward to target group 1. I want to change that, and I want to specify target group 2, and then I want to click Update. Now my load balancer has been set so that traffic going to port 80 will go to the first target group, and traffic going to port 8080 will go to the second target group. The next thing to do is to set up my cluster and my service. For that, I'm going to head back to the AWS console. Now we're going to create the Amazon ECS cluster. From the services, I can start typing ECS and select Elastic Container Services. I'm going to navigate to Clusters and select the option to Create Cluster. For the type of cluster, I'm going to choose Networking Only, because I want to use AWS Fargate to control my clusters and not have to worry about underlying infrastructure. I'm going to click Next Step. I'm going to give my cluster a name. I'm going to choose AFDS Cluster. I have the option here to create a new VPC for this cluster, but I don't want to do that because I'm using the default VPC for this instance. After that, I'm going to click Create. So you can see my cluster gets created. And if I click View, I can see the cluster is being provisioned here in the console. It'll take a few moments for this cluster to finish provisioning. I'm going to pause the video while I allow this to complete. After a minute or two, I can see that my cluster is up and running and currently in an active state. I don't have any services or tasks running in my cluster yet. That'll be the next thing to do in this video. Now that we have all of the underlying infrastructure created to support running my service, I'm going to actually create the service and have that run inside of the cluster that I just created. To do that, I'm going to leverage the AWS command line once again. I have here an input file which defines my service. The first thing I'm going to do is specify a service name. I've called it Product Catalog Service. I specify the task definition. Now this was created in an earlier step, and I can see the task name and the revision. I'm going to specify the cluster that I just created, AFDS cluster. For load balancers, I need to specify the target group that I'm going to register my instances against. In this case, it's going to be the ARN of the first target group that was created. I need to specify the container that this will attach to, in this case, Product Catalog 2, and the port that the traffic is going to be traversing on, in this case, port 80. For desired count, I've currently set that to 1. Now this is the number of container instances that are going to be spun up to support my load. In a production instance, you would want to have more than one instance of the container running. But because this is simply a test environment, I'm only going to use one. The launch type is going to be Fargate because I don't want to manage the underlying infrastructure. I'm specifying code deploy as the deployment controller because I will be using code deploy to deploy all of the updates to this cluster. For subnets, I've collected the IDs of the subnets that are in my default VPC. These are the subnets that Fargate can use to spin up underlying infrastructure for. And finally, I've specified the security group that I created and attached to my load balancer that allows traffic on port 80 and port 8080. The next thing for me to do is to go to the command line. I can see here that I'm in the directory that has access to the create service file that I've just been editing here, create service. And now I'm going to execute the AWS command line. Once again, I specify the credentials profile that exists on my local machine. I specify the region that I want to spin up my service in, US East 1, and then I issue the AWS command lines. So ECS, create service, and specify the CLI input JSON file as create service. Once that's done, I get the result of the return from the AWS command line. If I go here to Elastic Container Service and I look at my cluster, I can see that the product catalog service is up and running in my cluster. I can also look into the service details to see the mapping to the target group, the subnets, etc. And I can look at the tasks. I can see here that my service is running one task, which is the AFDS product catalog version 1 task definition. The next thing for me to do is to test the service to make sure it is actually still responding appropriately. So I can do that by once again navigating to the AWS Management Console. I can select EC2. I want to scroll down towards the bottom and select Load Balancers. From here I can find the load balancer I created for my project, AFDS Load Balancer. By selecting this load balancer, I can find the DNS name that has been allocated and copy it. I'm going to open up a new tab in my browser. And I can see here by browsing to the root address attached to the load balancer that I get my health check message, OK healthy. I can also call directly into the service to get the sample data returned that my service interacts with. So now I can see that I have not only the source code up into AWS, but I've got a fully running service that can be called from an API call. In the last segment, we built out the infrastructure for our deployments and got the service up and running in AWS Fargate, allowing for our containers to be managed with serverless infrastructure. The next stage in this video is to automatically trigger an update to the development environment once the build system publishes a new version of the container. To achieve these goals, we're going to use AWS services. First off, all of the code files that were used to stand up the infrastructure have been checked into an AWS Code Commit repository. This is a different repository to the one housing our application code. We will use AWS Code Deploy to update our running service and manage the cutover of the application. AWS Code Deploy will also monitor the application for deployment errors and allow us to roll back changes if something goes wrong. We will once again use AWS Code Pipeline to orchestrate the updates to the application. Now, let's jump back into the console. Back in the AWS Management Console, we're going to set up our AWS Code Deploy service to deploy our application into the development environment. As with all services, the first thing we need to do is set up an identity and access management role for Code Deploy to use. I'm going to start by going into Identity and Access Management. I'm going to select Roles, and I'm going to select Create a Role. I want to select Code Deploy as the service and Code Deploy ECS as the use case. The wizard's automatically going to select the relative required permissions for me. I'm going to click Next Tags and Review. I need to give the role a name, and then I'm going to click Create. The next thing I need to do is to set up AWS Code Deploy. I need to set up an application definition. So I will select Applications and Create Application, and then I need to give the application a name. For the compute platform, I'm going to choose ECS, and I'm going to click Create Application. The next thing I need to do is set up a deployment group. I'm going to click Create Deployment Group. I need to give the deployment group a name. For the service role, I can select the role that I just created. In the environment configuration, I can choose the cluster that I created previously and the service name that I created in the previous step. For load balancers, I'm going to choose the load balancer that's attached to my application. I'm going to choose the production listener port as port 80 and the test listener port as port 8080. target group 1, I'm going to select my target group, and target group 2, I'm going to select my target group. This will automatically allow Code Deploy to send the production traffic to port 80. It will then spin up the new instance on port 8080 and then swap the target groups around so that my code uses the new set of containers, but keeps the old set of containers ready in case of fallback. Under Deployment Settings, I'm going to choose Reroute the Traffic Immediately, so the traffic gets immediately sent to my new set of containers. Under Deployment Configuration, I have a number of options that I can use. In this case, because I've only got one instance, I'm going to choose All at Once to change the traffic completely over to my new set of infrastructure. If I wanted to test a small amount of traffic on the new deployment and gradually route traffic to the new deployment away from the old deployment, I could choose one of these other options. Finally, I have the option to specify how long my old application revision will be available. This helps determine how long I can trigger a rollback. For the purposes of this video, I'm going to set the value to a relatively short period of 5 minutes. However, in a production environment, I would probably want to extend this out. Next, I'm going to click Create Deployment Group. The next stage in this process is to create the pipeline, which will use the deployment that I just created to trigger the updates to the code. We can see here, if I go to look at source code and repositories, that I have an infrastructure catalog. This contains the files that I was using earlier. I had a file here that I used to create my task inside of AWS. I've made a copy of that called taskdef.json. And the only change I've made is to put a placeholder in for the image of the container as it's been updated. I also have an appspec.yaml file, which will be used in the deployment of the new updated application. These files have been checked here into the infrastructure repository. Now I can change over to pipeline. I have my existing code pipeline that controls the process to build and publish the new container when the source code has been updated. I'm going to create a new pipeline. I need to give my pipeline a name. Click Next. Under Source Provider, I'm going to choose AWS Code Commit. I'm going to choose the repository, and in this case I'm choosing the infrastructure repository that I created previously, and the master branch. I'm going to skip the build provider in this stage because I don't need to build anything. Under the deployment, I'm going to choose Amazon ECS blue-green. I'm going to choose the region, which I've deployed all my infrastructure to, the application, and the deployment groups that I've just set up. Under the ECS task definition, I'm going to choose source artifact and type taskdef .json. This corresponds to the file that I created, which has the placeholder in it. For app spec, I'm going to once again choose source artifact and type app spec Once again, this corresponds to a file that I have created in my infrastructure code that contains the placeholders necessary for code build, for code deploy. I'm going to choose Next, scroll down and create my pipeline. Now this pipeline is initially going to fail because I need to do some more edits to it to complete the process. As you can see here, it fails pretty quickly. First thing I need to do is click Edit, and I need to edit the source stage. I need to add an action, and I need to add ECR as a provider. I'm going to choose the repository that my image is being updated in. Because this is a deployment into the test environment, I'm always going to use the latest tag. This is also the default. I need to provide a name for the output artifacts to be used later in my deployment process. And finally, I'm going to click Done. I need to remember to save the changes I've made. I need to make one more edit, and this time to the deployment stage. I need to add an input artifact, being the image that's being pulled from the source repository. And then I need to define the variable substitutions that occur in my deployment. Here in the deployment stage, I need to add another input artifact, which is the image which I'm retrieving from the image repository. The other thing I need to do is dynamically update the task definition. And I'll do that by specifying my image and the tag that will be updated. You can see here this corresponds to the task definition file, and the tag name is there. I'm going to click Done. Save my changes and click Save. Now, if I click Release Changes, this pipeline should run again. My pipeline has run and it's completed going through the deployment for my application. We can see now that although the deployment is listed as in progress, it's waiting through the timeout value that I set in my pipeline to make sure that the deployment is completed successfully. I can click here on Details to open up the panel and see the code deployment details. I can see that my traffic has gone through. It's being rerouted to the new instance. And now I'm in my fourth step, which is waiting for 5 minutes. We can see over here that 100% of the traffic has been shifted to the replacement instance, and the original is still sitting and waiting. Once this 5-minute timeout is completed, the original task will be terminated and cleaned up. I'll allow this to complete, and then we'll demonstrate how a code change can be checked in from our source code all the way through to deploying into the development environment. Now that my deployment is completed and the original stack has been terminated, I'm going to go back into Visual Studio. Again, I'm going to make a trivial change to my source code. In this case, I'm simply going to update the message by my home controller. Save. I'm going to commit the changes to my source code, and then I'm going to look back into the AWS console. I can see here that once again my build project has been kicked off with the source code update. And triggered the build. Once this build completes, we'll see the execution, we'll see this marked as succeeded, and then we'll see the deploy to development automatically kick off as the new container image arrives in my repository. I'll pause the video now and allow this process to move along. Now that the build and the publish of the container is moved along, we can see that now my deploy into development has been triggered and the new code is being deployed into the development environment. As the deployment process moves through, we can check the load balancer and see that our changes have automatically been pushed through all the way from source code to our development environment. In the segments so far, Acme Financial Data Services has built a system that automatically carries the code changes from source code to build and deploys them hands-off into the development environment. The final step in this process is to implement continuous delivery. Continuous delivery extends this pattern to automatically roll out changes into the production environment once they've been tested in development. The good news at this point is the steps you need to follow are exactly the same as the steps in the previous segment. I've already created a second cluster, a new load balancer, and a set of target groups. Let's have a look at the changes in the console. Here in the AWS console, once again, we can go to EC2 and scroll down to load balancers. You can see here I've created a production load balancer, exactly the same as I did for my test environment's load balancer. If I go to Elastic Container Service, you can see I've created a production cluster. Just as with the development cluster, I've created a service that is running. And if I go to Code Pipeline, we can look at the container deployment. And you can see what I've done is added a second deployment step. I've followed exactly the same instructions as setting up the initial deployment step into the development environment, and only substituted the values for the production items. You can see by looking at the pipeline, as soon as the deployment into the development environment has been completed, which in this pipeline takes 5 minutes, we then roll forward and automatically deploy into production. You can see here in the production standpoint, we've shifted all the traffic into the new set of containers, and we're waiting. In this case, we're using the default timeout period of 1 hour. In a production situation, you would want to set the timeout in development to a much larger value to give you an opportunity to test the changes before automatically rolling them into production. You can see up here that the AWS console gives you the opportunities to stop and roll back the deployment in the case of a failure. Acme has accomplished a lot in this video series, so let's recap what we were able to accomplish in this session. Acme is no longer deploying the code from developer laptops. The updated deployment process is repeatable and reliable. Acme is using serverless containers to house their application. This means that there's no underlying infrastructure to manage in the form of servers. Updates are fully automated from checking in code all the way through deploying into production. This is a completely hands-off approach. And finally, all deployments are using a blue-green deployment methodology, allowing for zero downtime deployments and rollbacks. I hope this video has been helpful.